Welcome to Math 31. This is the lesson on absolute value inequalities, an extension of the previous one on absolute value equations. So, solving these, you just have to be a little careful with them, although they follow essentially the same rules as what we saw earlier. So, absolute value of x minus 2 is less than or equal to 4. Now, a question like this can be solved, just like we were doing before. X minus 2 is less than or equal to 4. And then the other version is negative x minus 2 is less than or equal to 4. So x is less than or equal to 6. And here we get negative x plus 2 is less than or equal to 4. So negative x is less than or equal to, subtract 2 away, and you get 2. And this will give us then x is greater than or equal to negative 2. So if we wrote this as with a lower and upper limit, we would say that x is greater than or equal to negative 2. So negative 2 is the lower limit. On the other hand, x is less than or equal to 6. Now, that seems believable, and when we do check, we can confirm this. So I'm actually going to bring up a new screen in order to do that, get a little more space. Now, the method for checking with inequalities is not quite as precise as it is for equations. So the typical method is to check value within solution set, and then we check a value outside solution set. And these are test points. So if you take a look at this problem, we were from negative 2 to 6. A nice easy one would have been x is equal to 0. And what we should get when we substitute that 0 in is a true statement. Now, we're not checking our algebra. If our algebra is wrong, then no check is going to fix that. All we're doing is making sure that everything's cool with our inequality. So we get negative 2, absolute value of negative 2, which turns into 2, less than or equal to 4. Now, this is a true statement. So I'm satisfied. The one within the solution set worked. It's true. So I believe that everything is going to work in there. Now, you can check more points, but this is good enough. If we got a false statement for something that should have been true, then we would have had to have rejected that. Now, if you pick something outside, let's say x equal to negative 3. So this becomes absolute value of negative 3 minus 2. It's supposed to be less than or equal to 4. So this is the absolute value of negative 5, which is 5 less than or equal to 4. And well, the problem is that's just not true. That's false. But that's what we want. We want the numbers that are outside to be false. They shouldn't satisfy the inequality. So note, values outside solution set should produce false statements. But ours is okay. So our final answer, negative 2 less than or equal to x, which is less than or equal to 6. Now, to simplify this process a bit, there are a series of rules. Now, what I did before to solve it just by going plus or minus around the absolute value symbol is fine, works. But we can also do it like this. The absolute value of x if the absolute value of x is less than or equal to b, or just plain less than, then this will always be true. We can set up a compound inequality where our solution set is going to be between the negative value of the b, and then the upper limit would be the positive value of b. So it should work. And then there's another rule that we can use for these problems. So the absolute value of x greater than or equal to b will always turn into x is greater than or equal to b, or x is less than or equal to negative b. Now you don't need to remember these because what I did previously always works. And in fact, when I solve them, I tend not to use them directly. I just go plus or minus and solve away. But the choice is yours. So let's go into a few other questions. Absolute value of x plus 6 is greater than or equal to 5. So I will do the fast method for this. So this would be x plus 6 on one hand is greater than or equal to 5. And then the other one, if you check back on the instructions, would be less than or equal to negative. Oops. So this could be x plus 6 is less than or equal to negative 5. And you see all that you're really doing is dividing the negative out and therefore reversing the inequality sign. So x is greater than or equal to negative 1, or x is less than or equal to negative 11. And then we check. So pick an x value that satisfies this. Now you have two inequalities. So some people check one in each, and others do not. So let's check first off x is equal to 0. Now this one should work because that's greater than or equal to negative 1. So absolute value of 0 plus 6 is supposed to be greater than or equal to 5. So it should produce a true statement. It did. So true. That's what we wanted. And then if you pick something less than negative 11, say negative 12, this should also produce a true statement. So this is the absolute value of negative 6. So 6 is greater than or equal to 5. So true again. Now if you pick something that shouldn't work, so you say x is equal to negative 2. Absolute value of negative 2 plus 6 greater than or equal to 5. Absolute value of 4 greater than or equal to 5, false. So I'm satisfied. X is less than or equal to negative 11, or x is greater than or equal to negative 1. And you could have used interval notation with this as well. Take a look at the next one. Now, I'm going to do this one the conventional way. And again, pause me and go through the question on your own if you prefer. Now, you could have done the shortcut method, gone plus or minus 3 and greater than 3, less than negative 3. I'm not gonna. I'm going to do this one traditionally. Bring the x over just to keep it a little easier to work with. And I'll write this as 2x minus 1 is greater than or equal to x plus 3. And then this would be negative 2x minus 1 is greater than or equal to x plus 3 again. Solve away. Bring the x's to the left, so I get x is greater than or equal to 4. This one will be negative 2x plus 1 is greater than or equal to x plus 3. Bring the x's to the left. In this case, I'll do that. So that's negative 3x. Bring the 1's to the other side. That's 3 minus 1 is 2. Now, when we divide by the negative 3, we'll get x is less than or equal to negative 2/3. And once again, we check. Now, a number that is within the solution set is -1, which is less than -2/3. So this one should work. So 2 times -1 minus 1 minus -1 is supposed to be greater than or equal to 3. So this is -2 minus 1 is -3, which is +3, and then plus 1. So 4 is greater than or equal to 3. True. So it worked. It should have worked. Pick a number that's greater than 4, say 5. 2 times 5 minus 1 minus 5 greater than or equal to 3. This one should work as well. So that's 10 minus 1 is 9. So 9 minus 5 is also 4, also greater than or equal to 3. So that's true. And then if you checked one that wasn't going to work, let's say 0. So 2 times 0 minus 1 minus 0 is supposed to be greater than or equal to 3. So this is 0 minus 1 is -1. So that's 1 minus 0 is 1, greater than or equal to 3. False. It should be false. So therefore, I'm satisfied anyways that the solution set is x is less than or equal to -2/3 in union with x is greater than or equal to 4. And that will suit you fine. Now the next few questions are ones that will don't really do anything bizarre, but they emphasize the importance of checking. Now x plus 5 is greater than -3. Now you could solve this one, but what I would advise you to do, note that by inspection, absolute value of x plus 5 is greater than 0 or equal to 0. It has to be positive. So positive like this, or 0. So therefore, it doesn't matter what x value I substitute in. Anything is going to give me a positive value. So XER. So you can save yourself a little bit of grief. Now, if you did solve this algebraically, and I invite you to do it, you will come to this point as well if you're careful with it. But it really makes sense to pay attention to what's going on with it. You still can solve it algebraically, particularly when you do a check. And if you did graphically check it, which is generally okay, what I would do in my graphing calculator is go y1 is equal to absolute value of x plus 5. Now, on your calculator, I'm not bringing up the calculator. I will do that sometime to take a look at these. But this is absolute value is ABS. And you find the ABS by going into the math function, pressing math on your grapher, moving it over the cursor to number, and you should see ABS right there. I don't think it's actually capitalized. And then the bracket opens up for x plus 5. So you graph that one. And then you graph y2 is equal to -3, which is just a horizontal line. And this is what you end up getting. And you can see that y1 is always above y2. So therefore, all x values will produce a statement where x absolute value of 5 is always greater than -3. So the graphical check is a good idea. If the question doesn't specify use a calculator or not, it's certainly an acceptable way to do it. Next question. 2x minus 7 is greater than or equal to 0. Well, this is another one where I would recommend that by inspection, it doesn't matter what we plug in. We will get a true statement. If you don't believe me, solve it the regular way. 2x minus 7 is greater than or equal to 0. Then negative 2x minus 7 is greater than or equal to 0. So 2x is greater than or equal to 7. So x is greater than or equal to 7 over 2. And for this one, we get negative 2x plus 7 is greater than or equal to 0. So negative 2x is greater than or equal to negative 7. So x is less than or equal to 7 over 2. And if you take a look at these together, these are all real numbers. Greater than or equal to 7 halves, that's everything 7, 3, 3.5 and higher, and then everything 3.5 and below. So again, x will be anything. It does check. And the check could be done graphically, or it could be done by, in a case like this, by inspection, or pick a number. But you can see, you take the absolute value of any number, negative or positive, guaranteed to be greater than or equal to 0. Now this last one is an interesting problem. I believe it's the last one I've got for you. So we solve this one. X plus 2 is less than x minus 2. And the other one would be negative x plus 2 is less than x minus 2. Now, a problem, right away, those x's, when we subtract them away, they're going to cancel. So we end up with 2 is less than negative 2. And this is false. Always false. 2 is never less than negative 2. So that half did not provide us with a solution. That worries me, but I move on to the next one. And I distribute the negative through, and I get negative x minus 2 is less than x minus 2. Bring the x's over to the left, and you get negative 2x is less than 0. So x is greater than, well, 0 divided by negative 2 is also 0. So we have a problem. We get a solution where x is greater than 0 should work, but the other one just ended up with a false statement for any x value. So this is a bit of a concern. So if you want to check this algebraically, pick one that should work, which would be, say, x is 1. And if you substitute that in, now this one, remember, should give you a true statement, because it is greater than 0. So 1 plus 2 should be less than 1 minus 2. And 1 plus 2 is 3. Absolute value of 3 less than 1 minus 2 is negative 1. False. So something that was supposed to be true did not work. So that means that's not going to be a solution. And to confuse things even more, if you plugged in x was equal to, say, negative 1. Now this should not work. And when we get negative 1 plus 2, supposed to be less than negative 1 minus 2, we get absolute value of 1, which is 1. Supposed to be less than negative 3, also false. So what's going to happen with this is that nothing works. There is no solution. There's no way that whatever number you put in for that x value, it's going to be greater on the left side than it is the right side. You can kind of tell by looking at the equation as well, x plus 2 and x minus 2. And graphically, we can see it. So you graph y1 is equal to the absolute value of x plus 2, and then y2 is equal to x minus 2. Get these two graphs. And here's your y1, here's your y2, and by inspection, y1 is always above y2 for the same x values. So if x is, say, 7, and there's nothing you could do about it. So therefore, there is no solution. There's no value of x that will make the absolute value of x plus 2 less than x minus 2. So no value of x will make x plus 2 absolute value less than the absolute, just plain x minus 2. So that's it for this lesson. The next lesson will be covering inequalities, but this time quadratic inequalities. Thank you for your time.